brings up our GUI, which is quite simplistic in its style so that it's intuitive for the user to use and easy. So we have all buttons disabled except for these two, so the user knows where to begin. So they either select a pre-existing annotations file, maybe they want to add more things to it, or they can create a new file. So I'm going to go ahead and create a new annotations file by clicking the button. Save it to a location, so I'll save it to our test data set and give it a name. So I'm going to just call it trial annotations or something similar like that. We hit save, and then we should find that it reappears here in our Finder. So that's a newly created annotations file right there. Go back to our program, we select that file that we've just created, and it gives us two new options. So we can load in our image dataset and we can load in our classifiers. So we'll go ahead and first open up our images, list of images come up here. They're filtered through by the compatible file extensions. We can go ahead and then open up a classifiers file, maybe this one. We can filter through these. So for the images, you can sort by name ascending. So that's already filtered through. So it's A to Z here, correct order. And then descending should give you the opposite way. For the dates, we can take a look quickly at the data of the photos. So all of them were created today except for the oldest photo of the lot, which was created on a different date in the past. So that's called E here. So then if we filter through by the date ascending, E should come to the bottom because it's the oldest photo. And then if we filter through the opposite way, it comes to the top as expected. We can also filter through by the classifiers, so descending and then back to ascending as well. So you can see M comes after D, that's correct. So we can also zoom in and out of our image pane. So maybe you want to readjust it. For the classifiers, you can add and remove classifier names to the file. So we click on the text edit and we can type in maybe mouse 2. We add that, reselect the file, the classifier file, and you can see that that has been added in. If we want to maybe remove it instead, we can select the classifier name that you want to remove from the file and then hit remove. Then when we open it back up, that should have been deleted. And yes, that's been deleted. So now we can maybe draw some shapes. So we can choose whatever shapes we want, maybe a quadrilateral. We can go ahead and hit save on that. Take a look at our annotations file, and we can see that on the lava photo that we're just on, the shape has been saved, and there we are. So we can go back, just close this quickly. Now we also have auto-saving that runs every 60 seconds, so I'm going to draw another shape on, but I will not hit the save button, and then we'll reopen the annotations file in a minute, and then you can see that it's been saved automatically. So I'll go ahead and draw maybe a hexagon this time. And then we'll wait maybe till 2018 on the time, and then we'll check the annotations file to see if any edits and changes we make and a new shape should be added to it. For now, we'll go ahead and maybe look at the shape editing. So we can copy the shape. We can delete maybe if we want. We can grow, we can shrink the shapes. We can even, if we want to change the vertices around, we can do that as well. Then once you're done with that, then you can go ahead and right click to complete edit. So you can do that as well. Maybe you want to assign a classifier to it, so we'll just do it there so it's more visible. and then we'll go ahead and assign that, and you can see that dog2 has been assigned. And then if we copy and paste that again over, the classifier is also copied over as well. So okay, we have a little bit more time. Maybe we want to delete some more stuff as well. I'll go ahead and check the annotations file now. And there you have it. You have more shapes being added to the photo as well. So that autosave has come through in the 60 seconds, and the autosave will continue to do so every 60 seconds. So there we are. Oh yes, another thing to notice that within the annotations file, the line index for from the classifiers file will also be saved. So here we have it. It saves the line index of the one that that you've just used. So maybe we can leave it like that for one time. We've gone through it and added and edited our shapes, annotated them. Maybe you want to exit for now. It's all saved. And now I'll show you the alternative of preloading it in. So we'll open up the trial annotations file that we've just created previously. Select our dataset folder, the same ones. And then if we take a look on the lava abstract, there we go. The data that we've created is still there, saved for us to reuse. Maybe we want to add some more things as a pre-step before we might use it on a larger scale projects for such as machine learning one. And then, yep, thank you for listening to this section. Next we'll be explaining the code.
So this is the implementation explanation part of the video. So we implemented it in Qt Creator, as you can see here. This is it running here. And we'll go have a look at the code. The UI is made in the design tab. And the code is all here. The code for the UI is here. It's auto-generated by the designer tab. And then the code for the buttons is in the view tab. We're following the MVC architecture, the view class here, view CPP, and the header file here. Take care of all of the graphical inputs and the information from the UI. So when you click buttons, these methods here are run. When you change the item selected in the list, these methods are run, and etc. etc. To update things on the GUI, we run methods like this, render lists, and whatnot. The UI, when things happen, when things are clicked, you'll see either if it's just to change things on the UI, you'll see things like this where it just calls methods on itself, or sets widget settings. On the more complex things, which require some logic and whatnot, you will see things like this here. When we want to say when the save button's clicked, you'll see the view class calling the control. So we'll go on to the main control classes. Following MVC, it takes care of most of the logic. It decides what needs to be done, depending on what the states are. The control class holds like state variables, so it holds what the currently selected folder path is, the classifier path to the files, and holds all these modes, etc. And you'll see the model and the view class can call the control and get all of these values using the get methods. They can set these values using the set methods, and then when another class wants to request something of, say, the view wants to request data from the model, it will be using these request methods to call across. So the view wanted the number of shapes of an image, then the view would call the control to run this method, and this method will request the number of shapes from either itself or from the model. Following the MVC architecture, the view and the model don't directly communicate. That's all done through the control. Then we'll go over to the model. That's here. So the model is our data container. It holds all the structures that hold all things like the classifier names, the image names. It stores the sorted lists if they're sorted. It stores lots of other information. It stores our objects, so the actual scenes, the images, the shape data is all stored in within the model. So the model stores images in these maps. It stores the addresses of them, which they're stored on the heap. And then in those images, we see that the images store all the shapes and lines and points that are on them in these other vectors. So the shapes will be stored here, the addresses to the shapes, the address to the lines, and the address to the points, and all the shapes and all the information on shapes are their polygon items, so they'll be stored in the polygon item custom implementation. And then the polygon item is just an inherited version of the graphical polygon, QGraphics polygon item with added implementation by us. So obviously that's stored within shapes are stored within images, lines are stored within images, points are stored within images, and the umbrella container of images is stored within the model. Therefore, all of our data is stored within the model, all access through the model. The methods in the model class are all about modifying the data, updating the data, sorting the data, etc. So all the things to do with data management, data requests. So when we're, say, loading a data set, this method will go to that method. So loading this data set, the control will request the model to load a data set. It will give it a folder path of where that data set should be. And then the model class would then go through with the correct filters to load up that data set into image names. It will then pass back that it will use a control method because it will need to do some logic. It will want to convert the Q strings that it has into a vector, etc. And yeah, so that's all data being read into the model. And another thing like loading classifiers, again, that's something that's done in the model. And then you have the save functions and whatnot like that. All of that's done within the model class. And then because of the way QGraphics items and QGraphics scenes work, all the interactions or the interactivity of buttons, sorry, not buttons, of shapes or the shape interactions are all done within themselves. So you'll see with the polygon item class that the right-click menu is all done within itself. When you interact with it, it recognizes that you're interacting with itself and runs its own methods on itself. So that's why you won't see that sort of stuff in the view class. It's just the way QGraphics items are implemented. For our multi-threading, for our concurrent programming, you'll see our thread class. This is used to have, it runs a Q thread. It basically just means that alongside the program, this thread's running every 60 seconds here, and it will then, every time it activates, it will just request from the control to run a save. So that's our concurrent programming. This will just be running constantly, even though the other parts of the programs are running in line. So our linked list is implemented here. That's our implementation. We just have an append and find size. Here. And then I believe that's it. You know about the points. The points are just used. We just needed to add some extra functionality to points on top of the standard QGraphics ellipse. Then yeah, I think that's everything to do with the implementation. So yeah, the overall architecture is MVC. You can see the way we've implemented that with the control, the model, and the view. They all interact with each other properly and all communicate with each other in the way MVC should. Thank you. That was the implementation part of the video. The next section will be testing.
Continuous integration testing. For that, we are using Jenkins. The Jenkins, my GitHub is linked to the Jenkins file. So when a commit is made through GitHub, it will come up on here, and when I press build now, it will create a build which is successful, as you can see here, when it does complete. And there was no changes as there was nothing uploaded to my GitHub. However, if I just look on the previous one, I did something for a test, and so that was committed on here, and it says the changes, and also it links to the GitHub itself. I'm going to go back, and on the console output it shows it's successful, and that's linked to there. Also, for my functional and acceptance testing, I have created about 74 test cases, which all show the testing for the project. And so this one would be an example of functional testing, as it's requesting an image from a folder. So that is one of the functions that are required to be tested, and so this passes as it we can request the image data names from the file explorer. As well as in acceptance testing, this one would be a great example, as the user can draw shapes, so like draw a point and then add lines to draw a shape, and there are all screenshots here as well, and screenshots in each test case as well. And with this, there's also screenshots about the continuous integration testing. There's also a test cycle which has everything included, and also has the workarounds for our test defects. The testing section for the demo. So first of all, we have created 3 different tests. So for a sorting algorithm, searching algorithm, and the linked list algorithm. First of all, we'll be talking about the sorting algorithm. There are 4 different test cases within this one, because we have done sorting for ascending classifier names, sorting for descending classifier names, sorting for ascending image data names, sorting for descending image data names. And first of all, would like to say more about the sorting ascending classifier names. So there are 3 names here: dog, mouse, and cat, and they are the names of the classifiers that we do have. And so it will go through this loop, which is a bubble sort, and so it means it will sort individually. So this will be swapped with mouse to get to the right bit, and again to find the right to find the level value. And so on here you can see I have run the test cases. All 6 have passed, and if I were to break it, so like on list 1, this is in order, however this is not. And so if I were to change the list to compare to list 2, and then to run that to show that they do work correctly as they're supposed to, it will say 1 failed and 5 passed. And it does specify where it's failed, so it'll be the test case number 1, which is this one, and it'll say the actual value that it wants to find, but then this is the expected from this 2, as that's the first name that's supposed to be in the correct order. Could do the same for descending classifying names, and if I was to change that back just to prove that it does work, and to run it again, if that's happened, and so there's 6 passed and 0 failed. So if I was to do the same thing again for descending, just comment that and uncomment that, and to run, so that says 5 passed and 1 failed, and in the same way it compares, says reason why, and so the actual value should be mouse, however on this one is cat because that's the first value there. Moving on to the searching algorithm. This is a search, this is a linear search. It's for classified names again. And so here are the classifier names: dog, mouse, and cat. And so I want to find the cat. This the search checks for the index 1 by 1 to find the index number 2, which is the cat, as it goes from 0, 1, and 2. And so it says that what the outcome should be, which index, so number 2, which is cat. And if I was to run this, obviously it says 3 passed, however if I were to change this, so to comment that out and decomment that, and to run again, and when this loads it says where it is failed, so what the actual one should be for number 1, but the expected is number 2 because that is the cat there, so it just shows that this does work. If to move on to the linked list, this linked list does work, however it's not been implemented in the program. It's in one of the files here, but it's not been linked in yet. However, if we were to do this, we would swap out a vector in for saving, and this would add the nodes for saving the annotations such as the image data names and the image, the shape amounts, etc. Obviously there are more, but if they want to open the file again, the node will return the file data by knowing which node it requires due to the HTF5 hierarchical format. And that is what we will do on our future work, but we have not implemented that yet. And just to show that it does work, it says 2 passed, but there is no data, so that's why there's not a 3rd pass as well. Thank you for watching. Hope you enjoyed our program.